Good morning, everyone. It's good to be here. So this is, as you can see, a talk about a particular technology called Globus and how we are using it, and you can use it, to address challenges of big distributed data science in the Jupyter environment. So it's going to be somewhat tutorial and somewhat just sort of hand-waving and slides. So here's the sort of problem that motivates our work. So this is quite there's a delightful video here, which hopefully will play. I work at Argonne National Lab, where we run some of the world's biggest supercomputers. And this fellow, Andre Schleifer, has been using those supercomputers to build very computationally expensive, very detailed and precise simulations of some funny property called stopping power, which is how long it takes for a particle to stop, or what resistance it encounters as it penetrates through a material. So this is showing hydrogen in gold, using 16,000 CPU hours, he can simulate what happens with that particle as it goes through the gold at a particular speed and a particular angle. And of course, as you go at different angles, as you can imagine, you get quite different resistance as you pass by different gold atoms. So we would like to be able to do the following. We'd like to take a set of such simulations, we've got a few dozen of them, and then use machine learning methods to build a predictive model of stopping power that would allow you to find out what the stopping power value would be for not just the values that we've actually simulated, but many other velocities, angles, perhaps ultimately other materials as well. And turns out that's not too difficult to do. And of course we do that in Jupyter notebooks. The only challenge is, if we're going to be doing this using Jupyter, is that the data we want to work with are large and distributed. So the data itself was taken from the supercomputer at Argonne and published into a large data repository for material science called the Materials Data Facility, which contains millions of records about materials. That's where the indexes is. The actual data itself sits on a data server at Argonne called Parcel, which has got many petabytes of data. And what we want to be able to do within our Jupyter notebook is to query the Materials Data Facility, initiate a transfer of the data that concerns us to another supercomputer, a system called Cooley that's designed for data analysis, run our machine learning models on those data there using parallel computing, and ultimately share the results with our colleagues. So in order to do that, we need a set of things. We need multi-credential, multi-service authentication. We've got to be able to manage within our Jupyter notebook. We want to be able to perform operations at all these remote places with appropriate authentication, authorization, and so forth. And we also want to be able to manage the movement of data from one locale to another. And these are the things that we are going to be addressing using Globus. How many of you here have heard of Globus? Oh, wow. Okay, so I'm not in a total room of neophytes. So I'll spend just a minute about it. So this is something we've been building since 2010. The Globus group is based at the University of Chicago. It operates this cloud-hosted service for the research community. It's a service that runs on actually the Amazon cloud, and provides a set of nice APIs and associated web interfaces and command line interfaces and so forth that let you ask it to do things like move data from one storage system to another. And there's 12,000 or more storage systems around the world, particularly in the US, that have got Globus Connect servers running on them. You can ask it to publish data, to allow people to access data, to transfer data from one place to another, and so on and so forth. A whole set of powerful capabilities. And as you can see, there's lots of nice stats. We've got, I think, 100,000 registered users. Tens of thousands of them are active at any one time. 1,000 services have been set up to use Globus authentication mechanisms and so forth. So what we want to do is to use these what I'm going to talk about here is how we can integrate these into Jupyter Hub and then use them within the Jupyter environment. So, as probably most of you know, Jupyter Hub itself has got this nice configuration. You come in from your browser. You interact initially with this hub system where you can ask it to create notebooks on your behalf, and then you can run those notebooks and they can do various things. Mostly they can do local things. What we're going to do is talk about how we can allow them to access resources anywhere, at least any resource that is accessible via appropriate OAuth operations. So your notebook is going to be able to sit there and reach out to many different places. So how do we do this? Well, first of all, we have implemented and committed to the Jupyter Hub repository a Globus Auth plugin, so that you can set up to use our so-called Globus Auth authentication. That's basically OAuth 2, which is a widely used standard. I won't go into more details on that. But by using this plugin, you then get access to actually hundreds of identity providers. So you can authenticate, as we'll see in a minute, to your Jupyter Hub's system with often your ORCID ID, your Google credential, your University of Chicago credential, your Harvard University credential, many other credentials of that sort. And then you can immediately connect out to a variety of different apps that are set up to accept Globus Auth authentication. And there are more than 1,000 of them registered so far. Okay, so that's setting it up is easy. I won't go through the through the steps, but it's described in the Jupyter Hub documentation. Once you've done that, we can then, well, basically what doing that enables is you can log in just as you would to regular Jupyter, except now you're doing it using Globus Auth. In so doing, you're asked to give a set of consents, which is, I think, a familiar concept from many websites nowadays, which get translated into tokens, which are then stored inside the Jupyter Hub user database. And then when you create a new notebook, well, you can access those consents, or the associated tokens, and use them to access various remote services. And we'll see how that works in a minute. So what does that let you do? Well, it means that you can, first of all, access a whole set of Globus services for data management. So within your Jupyter Hub, Jupyter Notebook, you can say move data from the University of Chicago to Amazon, or from Amazon to Harvard, or from Harvard to Lawrence Berkeley Lab, and so forth. You can access other services that we provide, like search and publication. And you can also access any other application that you've chosen to integrate with these Globus Auth mechanisms. So I'm not going to say too much about the Globus services, but let me just spend a moment on these. So one thing you can do is access our transfer service. So what does that let you do? I mentioned 12,000 so-called Globus Connect servers that are active at any one time. Most universities, most national labs, a number of companies in the US and internationally expose their storage systems via Globus Auth, so via Globus Connect. So you can access them using our mechanisms and initiate via a web interface or a REST API or a command line interface a transfer of data to and from that endpoint and other endpoints. And we support a very wide variety of storage systems. So object stores of various sorts, high-performance storage systems, POSIX file systems, and so forth. You can access data on any of these Globus Connect servers using Globus Auth authenticated HTTPS or GridFTP for high-speed transfer. This is all hidden behind our nice APIs and CLIs. You can also configure so-called shared endpoints that let you, for example, on your storage system on Amazon or somewhere else, manage who's accessing the data that you've placed there. And we'll see that a bit later. And for those of you who are perhaps from the National Cancer Institute or elsewhere, or work with sensitive data, these mechanisms are HIPAA compliant, so they can be used to transfer sensitive data, which is important for many. We also provide, you get access to a number of other services, Globus Search, which lets you create indexes of data that may be distributed over many locales. Globus Identifiers, which lets you assign identities to your data and then track whether where the data is and retrieve various metadata for it. And what we call the Globus Publication Platform, which lets us define publication platform pipelines for data that you may be creating in your work. So one system that's built on this. So these and other mechanisms can be used to build a whole variety, not only Jupyter notebooks, but a whole variety of other systems. So for example, the Canadian Federated Research Data Repository builds on top of this publication platform. Okay, so I'm going to just do a quick demonstration now to show how this works in practice. So let's see if I can make that work. It's kind of scary. I think I'm going to reboot things very quickly, but in the meantime I will continue on and tell you what I was going to show you, and perhaps we will not have the live demonstration, although I will give you the URL for it in a second. So what we've done is, as we do at a number of the events like this that we run, we've set up a Kubernetes enabled Jupyter cluster on Amazon. And I think I'm going to have to do it. I can't resist showing it. And set up so that you authenticate to this using Globus. So I come on, I connect to the system, I log on using my University of Chicago credentials. I then start up a server, connect to it. I'm asked as I connect what consents I want to grant to this new Jupyter notebook that I'm creating, and I'll give it the consents it needs to access various remote resources. And then fire up a Jupyter notebook just like you would normally, and I can go through it and start accessing the various identifiers and tokens that I have in my environment. I do that sort of explicitly to show what's there, although normally we do this using various nice Python SDKs. And then I'll start doing things like retrieving data from a data store at Argonne National Lab, running some local computations on that data store, training a machine learning model, for example. Although in this case, what I actually do is do a very simple plotting operation, and then put the result into another store and grant access to my colleagues so they can access that data. So it's a pretty neat little thing, but I think given my Mac's technical difficulties, I will not attempt to go further with showing it. Okay, let me start up my PowerPoint again. Well, we're back to where we started. So this is what I was going to show you. We use, by the way, this technology, Zero to Jupyter Hub. We really recommend it as a means of managing many Jupyter notebooks for these sorts of tutorial settings. This is where I was going to go. So if you want to actually try some of this stuff yourself, we do have the Kubernetes cluster running. It's supposed to be able to scale to about 100 people, so you probably won't be able to break it, but give it a go. Anyway, now let me move on and cover a few other features that we have underway here. So what I've shown you, I've talked about it mostly, but if you go to that URL, you'll see it in action. A set of APIs that can be, first of all, easily integrated into Jupyter Hub, and then once there, they can be used within Jupyter notebooks to perform authentication, to obtain tokens that you can then use to access for data access, data movement, data sharing, data search, all the sorts of things you want to be able to do if you're working with data that's bigger than will fit on your laptop, or even if you are working with data that will fit on your laptop, but you need to fetch it from remote locations. So as I've explained, these mechanisms can be used in your notebooks to access any data, essentially anywhere, and to secure any resource. I'd like to now go on and talk about a few other things that either are under development within the Globus team or have been experimented with. So one thing I wanted to touch upon is how we actually managed the various computational components, the notebooks and programs that were used to perform that machine learning application that I indicated at the very beginning. So here's the sort of environment that we work with at Argonne National Lab. So we have Jupyter Hub is running, and its associated notebook server is running the various machine learning notebooks that we've created to analyze Andre Schleifer's data. We authenticate it to it using Globus Auth and our institutional credentials, as I indicated. And then we have associated, maintained for use at Argonne and elsewhere, a container registry, a searchable container registry that we can use to find containers that meet a particular purpose. And then we dynamically deploy these onto things like the supercomputer that we use to actually train the models. So people can come in and work entirely within a Jupyter environment, but with computations being deployed on different computers depending on the needs of their application. And we make heavy use of this online data store called Parcel, which again is Globus accessible, Globus Auth authenticated, and easily accessed from within Jupyter notebooks. One other thing I wanted to say a few words about is how we incorporate parallel processing into our notebooks. So if someone was to study this piece of code that I showed at the very beginning, and let me explain a bit more about it now. So this is you're training and then running our machine learning model for stopping power, and this is here showing the results. We're computing, we're modeling using our machine learning model. In a few seconds, we can estimate stopping power at many different angles through the material, even though we've only computed at a few angles, which is a wonderful step forward scientifically. But this modeling process is still somewhat computationally intensive, even though it takes, particularly the training part. So we want to use parallel processing on our supercomputer. So we do that by adding this little piece of pragma up here. It says @Python app. So what this does is basically allow us to use a system called Parcel, a parallel library for Python that lets us specify via the notation I've just indicated, and here it is again, Python app, that a particular function is to be viewed as something that can be run in parallel and that will return a piece of data that we should wait on until it's available. And so here we're writing at the very bottom right a very simple parallel loop. Compute a set of an array of chunks by running this thing, compute features on each chunk in a NumPy array, and the result is a highly parallel computation. But in this thing here, we do the same thing, but instead we're computing stopping power for a whole range of different trajectories. So we make heavy use of this as a means of integrating parallel processing into our notebooks. It has nothing to do with Globus, but it is a powerful tool for high-performance computing in these Jupyter environments. The last thing I wanted to say a few words about is the work we've been doing with, this is much more experimental, integration of the Globus mechanisms into Jupyter Lab. So how many people here use Jupyter Lab? quite a few of you, so maybe this will be of interest. So far I've been talking about Jupyter Hub, fairly simple integration of Auth, and then one uses Globus mechanisms within notebooks, but there's no particular user interface experience. We've had a student working over the summer, smart young fellow, Juan David Garrido, to develop an integration of Globus mechanisms into Jupyter Hub, basically by developing a set of apps that will allow you to, first of all, authenticate and then access remote or local data, remote data, initiate transfers from one place to another, search remote data repositories, move data into your local Jupyter environment, and so forth. So I'll just show you a few bits of it. So here we are, we're authenticating. This is a standard consent page. We want to be able to, we want to allow this Jupyter Lab environment to know who you are, know some details about you, access your identities, identity information, simple identity information. Having done that, we then have a set of panes in the Jupyter Hub environment that allows us to browse our local storage. So our Jupyter Lab notebook is running somewhere. We have some local storage, so we can see that. But also to search remote storage systems, any remote storage system that we might have access to. And these could be just a few, could be dozens. Here we're browsing a few, we're searching one, we're finding a file on a remote storage system, we're initiating a transfer, it's appeared, and now we're opening up a notebook that we've just retrieved from a remote location into our local storage environment. So this whole notion of all the things that you can do within a notebook using API calls, we can now do using Jupyter Hub user interface components. Another important part of Globus for many people is its search capabilities. This is what its publication and search capabilities. So these are what underpin, for example, the materials data facility that I mentioned briefly earlier. So we can also go ahead and search remote databases. So we've got three here. The materials data facility, MDF. There's a database of neuroimaging data. And one of parallel computing performance data. We're going to search the materials data facility, select a piece of materials data, and retrieve its metadata. So you may be able to read the fine print, but basically we've got some information about some crystal data. And we can then go ahead and retrieve that locally. Perhaps we can retrieve a whole set and retrieve them locally for modeling. So this is how we would proceed if we wanted to do the stopping power calculation in a user interface environment rather than remotely. We'd browse the materials data facility, select the data we wanted, initiate a transfer, fire up our stopping power computation, and then transfer the results perhaps back to the materials data facility for further publication. Okay, so I think I will have time to go quickly through the notebook. We'll try that again in a minute. But first of all, let me just go through the last two slides before we do that. So I wanted to mention, obviously, a lot of people in the Globus team and others are involved in this. So I do want to mention that two of them are here, Rachana Ananthakrishnan and Mike Papka, who's director of the Argonne Leadership Computing Facility. So if you see them, feel free to ask them questions. He knows everything about high-performance computing, and she knows everything about Globus. Vas Vasiliadis is here as well. I didn't know he would be here, so I didn't put his picture up. But hey, Vas, do you want to wave your hand? You want to know Globus things? He knows everything as well. So let me tell you where you can go for more information. So the Globus APIs, lots of online documentation. Use with Jupyter. Well, you can try this Jupyter demo. How many are doing that at the moment? A few? Is it working? Good, I would hope so. There's a long blog post with a URL that you won't remember, but you can probably find it. And the more future-looking stuff we can talk more about. Let me try, see if I can get this. this thing going. Okay, this is working now, so good. So I'm going to, this is my, the example that I was going to talk you through, and now I can do it. So let's see if we can make it a bit bigger. So I signed into Globus, and I've previously signed out. It normally keeps my sign-in information active, but I wanted to show you this. So it's going to ask me to sign in. So this is what you see in your Jupyter Hub environment. So I could sign in with any one of dozens, hundreds of different credentials. Here I'm going to use my University of Chicago credential. I could use Google or Orchid. So using OAuth, yeah? What's up? This is not working? Is there a problem?
No, what do you want me to? Oh, sorry, I had asked about having...
Anyway, we'll continue. I'm CI login. We can sign in. We're now a richer set of consents because I want to be able to do more things. Proceed, I'll grant all those consents. And now I can start up a server running on Amazon, I believe, although it doesn't really matter where it's running. Once it's started, of course, I can then proceed to access my Jupyter notebook, Globus. There we go. I'm going to go to the JupyterCon one, which I think hopefully some of you have found. At this point, I've authenticated. It's requested scopes from me, and we've created a Jupyter notebook which has access to all of these tokens that allow me to access other resources. So you can see we've got pretty standard stuff here. We can retrieve tokens from the environment. We can look inside them. So here's the tokens I have. I have my ID token, which represents information about me. A Globus Auth token that I can use to authenticate to others. We've got tokens that we can use to access the Globus Identifier service, the Petrol storage service, the Globus Search service, the Globus Transfer service. I may or may not want to use those. And then I can go through and examine the credentials, which I won't do, but I will show you how we can immediately, within this notebook that I just fired up, go ahead and retrieve data from a remote storage server, perform some computation, put the results onto a mass store, and then share a link with others. So here I'm doing, you can see an HTTPS GET operation, pretty straightforward because it's public data. I plot the result. I won't do all this. And now I'm going to initiate a transfer of the new plot that I've created to this Petrol storage service. So here I'm constructing a header. So this stuff is all wrapped inside our nice Python APIs, but we wanted to show you how it worked. So I'm retrieving a token from my environment, setting up a transfer, and moving the data from, as we show here, we're moving the data from Amazon to the Petrol storage service. Okay, I think I'll stop at that point. So, so to remind you what we've seen at this point, I will risk another application movement. Here's where you can go for more information, and I'm happy to take any questions that you might have. Yeah. And I actually left time for questions if I calculated correctly. Yes.
Yeah, so there's 8 minutes.
8 minutes. Amazing.
Okay, so could you repeat the question?
Yeah.
Are these slides going to be available?
Are these slides going to be available? Yes. Well, you can get them from me. Will you be sharing them also? We don't know. So you can get them from me, and if JupyterCon publishes them, then that we'll get them there as well. But there's my email address at the bottom, foster@uchicago.edu. Yeah.
So Ian, you authenticate with Globus. How do you get the petrol token? Is that because of what's on the consent page?
Yes, that's right.
And
yeah.
What happens when you want to hit a cluster with two-factor authentication?
Yeah, so Globus so Globus can handle two-factor authentication, but you will have needed to authenticate yourself previously to that, and then we'll generate the appropriate token. Yeah. Yeah.
How do you handle like token timeouts? Like, what if you have a timeout or a token that expires after 15 minutes?
Yeah, so mostly the tokens we deal with last for longer than that, 12 hours or so, sometimes much longer. That's obviously a policy decision of the resource provider. So we can, at that point, we can detect that they've timed out, and then we'll tell you where you need to go to refresh them. Typically, posting a URL that you need to follow to refresh them. Yeah. Yeah. So we can't avoid the fact that people like to manage the lifetime of their tokens. But remember, these are, so Vas, you want to say something?
I was just going to add, you can also use refresh tokens as part of the request that you make originally to get a refresh token.
Okay.
Your application can do that automatically as well.
Yeah, so the question was about token timeouts, and the comment made by Vas was you can build into your application refresh tokens, which will automatically refresh as you proceed with your computation. Yes?
So, you mentioned a lot about moving data
Yeah.
from one place to another place. There is always this concept about bringing the computation
Yes.
data. So, why do you move so much of the data? Or what is the model?
Right. So, that's a common question. Why do you move the data? Two answers. Of course, often if you can move the computation to the data, that's a wonderful thing, and you can use Globus mechanisms for that as well. But for better or worse, data often ends up being in the wrong place, and we help you put it in the right place. So, for example, the example I gave you sort of illustrates that. The materials data is stored on this Petrel server, which is designed for high-speed access, long-term storage. We want to move it to this computational platform where the storage is intended to be used in a more a temporary manner. We often find data gets created in one place. People want to merge data from multiple sources. They only have a certain allocation in one place. There are all sorts of reasons why people end up wanting to move data. Not to say that if you can avoid it, you shouldn't. Yeah, so one thing we are busy, part of our goal with this continued yet ever deeper integration with Jupyter is to allow people to deploy Jupyter notebooks on where the data is and run the computation there. And when that works, that's going to be wonderful. Yeah.
You mentioned in a bullet that the Globus transfer platform is now HIPAA compliant. Can you say a few more words about what sort of confidentiality guarantees come with it?
Yeah, so the Globus transfer, just think what it does. It lets you move that particular part of it lets you move data from A to B. A and B are both storage systems managed by other people. So the things that we're concerned about in validating that we are compliant with these policies that prevent revealing of personal health information is that the system itself is secure, that we don't store or transmit file names in the clear because they can have personal health information, that all information is encrypted when it's in motion, and a few other things around how we manage the actual service to ensure that it can't be compromised. So the main changes we make to the service, apart from how we operate it to be very secure, that we obfuscate or encrypt file names in transport, and we encrypt all the data as it's moved. Yeah, so fortunately we're not in the business of storing data, we're just in the business of helping people move it and keep track of where it is. Yeah?
So if I want to transfer data from like one university cluster to another university,
Yeah.
does the data go through Amazon? Or?
Oh yeah, no, good question. No, it does not. No, so a big focus of so you can think Globus running in the cloud is like the FedEx headquarters, and we're moving data by the fastest possible route from the source to destination, controlled by this cloud logic. So, and we do that by using a feature of the underlying protocol that we support, GridFTP, called third-party transfer. So most big universities and labs nowadays have these science DMZs, so-called, very high-performance systems, data mover systems with arrays of data transfer nodes, all of which have Globus installed on them. So if we want to move data from, say, Harvard to Argonne, you initiate the request. Globus sits there and negotiates with the two endpoints and sets up a high-speed transfer that may use many streams, multiple servers on each end, that can get a large fraction of the peak performance of the underlying network. I think we've only got like a minute or two left, so perhaps we can stop at this point. Thank you very much for your attention.